Okay.
Okay, it's okay.
So have you been able to arrange that component like this? Apart from the routing. Have you been able to do that? Well, I don't think we don't really have much time, so I don't want to go back to the schematic because I think we are perfect with the schematic design. But for this PCB design, there are some other things I want to let you know. Apart from component arrangement, the position where you have the rep test for each component must be clear. Nothing must what? Block it. It has to be in a way, in a clear position. For example, look at this is T1, is visible, nothing is blocking it, and it must not be placed under the what component. Whereby if T1 is here now, once you put the transformer on it, you can't really know okay which what was the ref desk of that what transformer. Are you getting? So look at D12 is okay, D4 is fine, C4 is where it is somehow tight, C12 is okay, D2 is okay. What about D3? Bad. U2 is okay, C32 is okay, but we can still manage to move it out of that point. J2, so you can see that there are some components that are not clear. Once you click on it, you see their what details here: ref desk, their value, name, pattern, manufacturer, and any other what additional information. You can see. So to move it, to do that correction, most times I use short code. I use F10. Once you press F10, you'll be able to move what? Ref desk. So for example, now once I press F10, you can see that the pointer can highlight the ref desk. You can see if I press escape now, if I move my pointer, it can't highlight it again. So if I press F10, that means I've enabled the what? The mouse pointer to be able to move the what? Ref desk. So this what? D3. So I can move it to where? To a position where it is what? Clearer. Even this C4, I can move it to where it will be what? Visible. C3, I can prefer to move it to this point after pressing F10. can see you can move any. Okay, let's leave this one here. Let me move J2. J2, let me leave J2 here. It's visible. It has to be visible. R2 is okay, R1 is not okay. You see? C2 is okay, but J1 is not okay. So, so it is fine. I think we get that. Can we do that in our board? So, if you don't remember the using F10, just come to what? View. What's that? Text. So that's it. So now that I'm exit, if I go to view, you can see that it has what? Uncheck it. If I check it now, I can move what? Component. So that's it. Then another thing I would like to put you through is for a PCB design like this, you may want to have you may want to place it inside an enclosure whereby you need to put mounting holes, or you are trying to you have to mount it on a particular plastic or frame or anything. So you can also mount what? Holes. Can you see it here? Place what? Mounting holes. So you can come here, place the holes based on your what? On the type of casing you what? You want to use. So now I've placed how many mounting holes? 4. So you can increase the diameter of the what? Of the holes. Can you see? Let us use let's use 2. Then so let's use what? So the size of the mounting hole depends on your what? On any enclosure, or maybe you are tightening to a frame. So that's it. So we have what? 4 mounting holes. Then please let us always remember there is one thing that is very important after you are done with your PC design. Always define what? Origin. Always define what? Origin. Now I told you most of the machines that will be used to fabricate this PCB use what technology? CNC technology, which is what? Computer numeric what? Control. The software may display this PCB board for you in a pictorial form. You understand me now? But inside the software, it's representing each component position in terms of a what? Graph. You understand me now? But you are seeing a what? A picture on the screen, but internally is representing each position with a what? Graph. So if you are to define origin, this is the point at which we what? Define origin. This point. For all PCB software, this is where you define what? Origin. At this edge, left down. Just like your graph. Abi, where's the origin of your graph? Uh, 0, 0. So if you look at this board now, look at this point here. It will show you this thing. Look at when I put my pointer here. What is it showing? It's showing minus 71 and what? 67. That means we've not defined origin. So to define origin, you can just come here and click on what? Where is define origin? Hmm?
It's down. Other view.
Okay.
It's on like after display origin.
Okay. Okay. Did this is okay? The screen. Oh, is the screen is not.
I think you use the arrow key to go down. The screen is
Okay. Okay, it's the screen. Coming. One time. Normally, I just use a short code. I don't know. Define what? Origin. So you can define origin by what? Mouse pointer or by, but use what? Mouse pointer. Click on what? Mouse pointer. Go to this edge. You can see it has show. Once it shows that box, that means you are the what? Edge of that what? But click on it. It has been defined, but it's telling you if you want it to display, you should press what? F1. So that's it. It has been what? Defined. So if I want to display it, just press what? F1. You can see. So now if I move this pointer to this point now, what's the board outline now? 0, 0. Because if you don't define origin and you send this file to the lab, jargon, so it will be out of it won't be useful. What they will see will be different. So they may be seeing maybe from this point of your board. You understand me now? So if you don't define origin, what they will be seeing maybe, let me say for example, where's this screen is just hiding different icons from me. Let me just see guys. They may just be seeing this side because their software will recognize it as what? That okay, this point is what? 0. Do you understand? So that's one thing about what PCB design. So after that, after you've done all this, you need to what? Click on what? Save. You have to what? Save. Let's talk about PCB design for manufacturing or fabrication. Àwọn bíríjì lágbára. Press F. No. Verification. To everything is under view. Yes. Units. So in PCB design, before you can design a PCB board, you must have a idea about electronics. You must be able to identify what components. You must know their what. You must have knowledge about what electronics, right? Then after that, you must once you know electronics, that means you have knowledge about what graphical symbol, and that means you must have knowledge about what schematic. No, you can know all this without knowing basic design, right?
Yes.
So if you have basic knowledge, if you have a good back knowledge of about electronics, grammar symbol, and what schematic. So once you have good knowledge about this, for you to now go into what PCB design. For you to go into what PCB design, you have to understand component what patterns. Component what patterns. Because when you know about electronics, you have good knowledge about the graphical symbols, and you can design your schematic to standard one. You also need to be able to understand what component patterns that we attach to each of those what graphical symbols. So after that, you now move to what PCB what design. Conversion of what of schematic to what to PCB. Of what schematic to what PCB. So while you are doing this, that means you need a card what software. The card what software for what PCB what design. You need a card software for what PCB design. Then you must understand PCB what design rules. You must understand what PCB design rules. By complying to IPC and what ISO standards. By complying to what IPC and ISO standards. So any PCB card software you are using, you understand? Any PCB card software you are using, they are designed based on this what standard. They are designed based on this one standard. So while you are using all those PCB software, it has a function that does what design rule check. So this design rule check is in compliance with what IPC and what ISO standards. Are you getting me now? So no matter any type of PCB software you have, the end results are always what the same thing. They are always what the same thing. But when you are designing for manufacturing, when you are designing for what? For manufacturing, or for let's say when you are designing for fabrication, understanding. When you are designing for fabrication, the expected file that you need to export from a design. When you design your PCB finish, you don't give it out to the fabricator. You don't give your design out to the fabricator. You don't give them the schematic. You don't give them the PCB file. You don't give it to them. The expected file that you export are what? Java file and link and what? This part. I will explain everything one by one. Then another one is what? Step 5. Step what? Step 5. So those are the 5 that are needed. So let me explain this to you. So for you to have this board, to be fabricated, and you want it, oh, sorry, pop-up is there. So just click on update. So now for couple. So for any type of CAD software you use, hello, for any type of CAD software you use, are you getting me? For any type of what PCB CAD software you use, when you export your GABA file, you can view that GABA file in any other what PCB CAD software. Do you understand what I mean?
Yes.
If I use deep trace for my design now, if I export that GABA file, if I use another software which is Eagle will be able to what? Open the what? File. You understand me now? So other software can open the what? File. But they won't have information about all the components you use. It will open the file. I'll still give you an example. It will open the file, but they won't have all these details. What they have is the traces, the holes, that's all, the copper core, the board outline. Just for them to what? View. They can't what? Do any editing. Are you getting now? So that's why I said no matter software you use, what you need to do is just what? Export your what? GABA file. So if I'm using deep trace now and I'm sending this to another PCB fabricator to fabricate PCB for me, they may decide to use another software to open it. So for them just to what? Open it and print it out. To open it and what? Print it out. So the GABA file comprises of different what? Layers. Of different what? Layers. Look at this point here. What the GABA file will do is they will see this PCB like this. Then after seeing this PCB like this, the next thing they can see, they won't see objects, they won't see properties of component. What they will only see is what? Layers. What they will see is what? Layers. So the only thing they can do here is to what? Maybe remove some layers or not. For example, font has its own layers. RevDesk has its own layers. These holes you are seeing have their own layers. This shape of each component, they change over to Disco. Change Disco color no local. Disco no like this. But some people still call them NEPA. They are worse now. I work with them very well. Wọ́n lé gbogbo ẹ̀jìnà kúrò bí wọ́n á gba àwọn tó finance manager. attention. Our business manager. See,
Press F10 to move the components,
grab this.
but we want to change its direction. Maybe, yes, we want to rotate it.
Press and this thing.
We press what?
Space bar.
Space bar.
It's not rotating.
Yes, it's not rotating.
Don't you share now? Come on, rotate.
After, do I need to remove the F10 again before rotating it?
No, that's to be on it. You have to. Why the mouse is on it? Why you are still holding the mouse? Press space bar.
Sorry. So please can you move the blanket?
Okay. Yes.
Thank you. It's going to work now. Yes, yes,
Better?
yes. Okay.
So looking at these layers now, we are talking about GABA 5. GABA 5 just give you what information of all the layers here. So if I click on, if I want to check top dimension, we don't have any dimension on this board. For example, this is an example of dimension. Look at this. Assuming I try to take measurements of this board, of the length of this board now. So this is classified as what? Look at it. What layer? Top dimension. So if I go to dimension and I check what? To go. You understand now? If I go to top assembly, do you see what is representing top assembly? This let me zoom it very well. Board edge. Board edge is classified as what? Top assembly. You understand? Top seek. Do you understand? So each layer has what they represent. This is top seek now. So those are the only editing they can do. So for example now, if your fabricator open your PCB design and they see some dimensions on the top board, they can't edit. The only thing they can do is just to click on their own software to remove what? Top dimension. So it will remove all the what? Dimension. Because top dimension is not necessarily on your what? PCB board. The most important things are what? Top assembly too is not what? Important. Top seek is what? Is very important. Top outline, didn't make use of anything like related to that. Top courtyard, didn't use anything related to that. Top marks, we use it. If you see the this thing,
Bottom.
the this thing, the true holes, the holes. So it can't be bottom. It's top. So it has no. I'm looking at. I'm seeing something. That's what I'm trying. It's not. Mhm. I'm not seeing it. On what? On which component? Okay, 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 okay. Okay, it has effect on those ones too. Yes, I can see it. So that's what top marks. I understand what you mean. Top paste. You don't have anything like top paste. It has no effect. Top terminals, no effect. Top, no effect. Now you go to what? Bottom. If you go to bottom, you can see that means copper pour for what? Bottom. Copper pour for what? Bottom. Let me go to the top again. There's one thing I want to tell you. This top paste, which one? Don't show you. Top mask. This one that is showing that is having little effect on those components. Top mask is used sometimes if you want to expose your trace. If you want to expose your what? Trace. Do you understand what I mean by trace? Look at this trace now. This track. If you want to expose it, you don't want it to be laminated with what? Green film. Normally, when you fabricate this board, this part is conductive, but it has been laminated with what? Green film. Insulating the what? The trace. That green film does what? Insulate the what? Trace. But it won't insulate this soldering point. You understand me now? If it is not insulated, if you try to solder this point, the lead will spread over the what? Trace. It is spread over the what? Trace. Are you getting me?
Yes.
Uh-huh. So that's it. So assuming you have a board and you want this trace maybe to be exposed from this point to this point, you have to make it what? Top mask. Then where do we normally use top mask? We use it in case you have a trace whereby higher currents will flow through that what? Trace. For example, inverter circuit board. There are some traces that carries what? High voltage and high current flow through them. So we make the width of the trace bigger to like maybe 4 mm. You understand? Because we don't want to use wire. So you now expose the what? Trace. After the exposing the trace, you will now deposit lead to thicken the what? The trace. So it can have enough this thing strength to carry what? High voltage and what? High current. So that's why we make use of what? Top mask.
Sometimes we put maybe conductor and we now solder it along that part.
But for us, we don't do that. We just what? Make it top mask by exposing that what?
But do you mean if there is high current, it can't break it, it can't break
No,
the
no.
laminate.
If you thicken,
the lead.
you know, don't break the leg. The leg is always thick, very thick. Very thick. So, but if the rating is if the rating is too high, the better we just use what? Cable. Jumper cable. You solder the cable, you bend it, cuff it. It should just be like a jumper cable. If the rating is too higher, than because there are some softwares you use to calculate your trace. Whereby I want there will be a voltage across this trace and the maximum current flowing along this trace. What should be the what? The width and the length. You understand? So that's it. So that's top marks. So if you go to bottom now, you are bottom, abi? This bottom. Bottom means what? The copper core for what? Bottom. So if you give your Java file to a PCB fabricator and they mistakenly uncheck this is how your PCB will look like after fabrication. You understand me now?
Yes.
So we are discussing about Java file. Please take notes. So top. So now, which other one? We don't have bottom terminals at all. Bottom paste, we don't have. Bottom mask, we don't have too. It's just trying to show. Bottom mask, the same thing with the top mask I explained. The same thing with what? Bottom mask. We don't have bottom courtyard. We don't have outline. We don't have bottom seek. We don't have bottom assembly. We don't have bottom dimension. No dimension at the bottom. I explained the bottom to you, right? So then we don't have board cutout. Okay, we have board cutout, sorry, which is the board outline. You can see it. Can you see it? This. So we can change the color. Which color should we use for it to be more visible? We should make use of what? White. Let's see white first. You can see it now. So, but that's bottom what? Cutout. So So if you can see, there's no top cutout there. You see? So this represents for both sides because it is just one cutout. There's nothing like you are cutting out the board at the top and at the what? Bottom. So that's it. Then uh, there are sometimes you can see boards and you see them isolating board whereby they have cutout in the board. So sometimes you can see boards with this thing logo. You see logos on them. Hello? For you to place logo, just come here. Place a what? Picture. So if you click on place a picture, it will ask you where do you want to place the what? Picture. Let's say here. You get me now? Once you drag it, then you go to the what? Picture. Please let's be doing it as if I'm too fast. Pictures. This is the line we think of it. Okay, let me use this one. So it's because of the size, if you want to do that, you have to start. This thing is not that clear. So sometimes you see some companies logo on this how they do that. You get to know. And there are sometimes you see some cutout in boards. Sometimes they use it to isolate AC from DC. How do you do cutout? Oh, just come to this one is what? Draw shape. If you draw a shape now, let me say I want a good isolation between this these two sides of the circuit. You know, this AC and this DC. If I want a good isolation, I can just what? Draw something like this. But I have to change the ref there. So you see? I will change it to what? You can say property or any changes you do and this is bringing error, just do what? Update. So can you see the board? What happened?
3D. Okay.
There's a cutout. Can you see the cutout? So if you have very high this thing, interference here that you think that can radiate to this side of the board, sometimes we use a what? Board cutout. I just draw a shape. That's all I did. Look at it. Any shape here you can draw. Okay, let me use this now. Okay, at the top no matter here. You understand? You draw it at the top. Oh, Ctrl Z. Look at this now. I want a hole here. Uh-huh. It is just a normal shape as it is. And if you see, it's just what's the type? It's a top assembly. So you can come and you see, I've changed it to board cutout. Then if you want to change it to, you can just come here, right click on it, properties. Anyway, you have different options. You can come to properties to change it, and you can as well come to where? To this list to what? To change it. So Ctrl Z. Let me lock this transformer. So it won't be moving around again. So I have a board cut out here right now. Am I right? So if I view the 3D now, okay.
Hello?
Can you see now?
I'm not hearing you. Can you send the
You have
message?
what? The cut out on the
Hello?
board. On the board.
Okay.
You have a cut out on the
Okay, my
on the board.
department.
So now,
Oh,
if
are you
you
coming to my
send
lab?
your PCB, ṣé kí ni yóò show bẹ́ẹ̀?
Okay, send the message. I'm in a meeting. Send the message.
It was giving an error. Tell it when I want to close it. So now, assuming you send your file to someone, to the fabricator, I told you they won't have information about the properties and objects. The only thing they would see is what? Layers. So if they mistakenly check which one now, let me see. If they mistakenly uncheck this, if they mistakenly uncheck this, what will happen? They're still there. That one is for them, sha. It won't show on their listings. So if they mistakenly open it, uh-huh. If they mistakenly uncheck that, the cutout won't be what? It won't be there. That's it for what? GABA file. And GABA file, we only when you, GABA file is for you to print out this board in black and what? White. All these layers you are seeing will be in what? Black color. But all these parts without traces or copper pot will be in what? White color. That's the information the GABA file gives them. It just gives them the pictorial view of your what? PCB design in black and what? In black and white. In black and white. So all those things you are going to see them when you get to the fabrication what? Section. That's it. So the second file you are giving them is what? Drill what? Drill file. Drill file will give them three information. Three what? Information. It's going to give them the what? X, Y, and Z position. What did I say? X, Y, Z position. And the diameter is more than 3. X, Y, Z, and the diameter of all the holes on your what? On your PCB. Do you understand? It will give them what? X, Y, Z, and the diameters of all the holes on your what? PCB. What's the meaning of XY? The coordinates of each hole. What about Z? Depth. The what? The depth. You know, in PCB design, apart from we discussing about single-sided or double-sided, we also have multi-layers PCB. We have multi-layer what? PCB. That has what? 4 layers. That has what? 8 layers. So if there's going to be a vias, there's something we call vias. If there's going to be what I mean by vias, if there's going to be a connection from layer number 1 to layer number 4, that means that kind of O will have what? X position, X and Y position coordinates. It will not have what? Z. Do you get what I mean? So, but in this aspect, we are just dealing with what? Single-sided and what? Double-sided. So the Z coordinate will just be the Z. This thing will just be what? 0. So a drill file will give position of what? X, Y, Z, and what? The diameter of the what? Hole. So the diameter of the hole is what the machine will use to request for what? Drilling bits. It will tell them what? Insert drilling bit so mm. So when it's finished drilling that one, it will stop. It will request for another what? Drilling bit for the next hole to be what? Drilled. So those are the two information you send to your what? PCB fabricator. So when it comes to that's for your what? PCB. And when the next thing after you have your PCB, what's the next thing you do? Yes. Placement of what? Components. Placement of what? Components. If you are, there are two ways you place components on PCB. It's either you place it manually or you make use of what? Pick and place machine. Pick and place machine. Pick and place what? Machine. So I think I explained the meaning of POM last time. Bill of what? Material. The bill of material consists of all the components. So you don't have to start writing or doing the list again by yourself. It will, even though if you have, it will show you the quantity of each component. So the pick and place file. The pick and place file, if you are doing it manually, you don't need it. You don't need it. What you just need is to what? Pick your component, come to C1. You click on C1 like this. What I'm placing here is what? 1000 UF capacitor. Insert it, solder it. That's manual soldering. No? Come to what? C2. Click on C2. It will show you the components. You have the, you what? You pick it up by yourself and what? Place it and you what? Solder it. Click on C3. So that's the beauty of using software like this. So if you want to solder, you know, okay, you won't mix up components. Because if you have the components inside your paper, it will sometimes it may not be easy for you to get it. You start searching for it at this C3. But when you have a software like this, once you click on it, it will what? Highlight the position of the what? Component. And you see the value of the what? Component. So now, but if you are using a pick and place machine, you will what? Export the file. You now send it to the company that will do the what? Pick and placement of those components. So those companies, it depends on how you negotiate with them. You understand me now? Because this pick and place file, we give what? The X, Y, Z, orientation, value of all your what? Components. You can limit what you want the software to what? To do. So if you negotiate with them that, okay, buy my component for me, that means you are going to give them what? X, Y, Z. X, Y, Z is what? Coordinate of each where the component will be. Z is the depth. And what do I call it? Orientation. You know what we mean by orientation? If the component will be 360 or 180, you understand now? So for this component now, you can see it is a what? It is what? 180. It is what? 180. What about this one? When it has polarity, it's different. Okay. Please understand. When it has polarity, it is different. Let me explain to you. You see what I mean now. Without polarity, it is still easy. I want to copy. Let me just copy this out. So, Control C. Control V. Paste. What's this? It has 4 different.
Yes.
We have 0, 3, 6 like this. Uh-huh. So what rotation is this now? What is this one? What's this one?
The polarity should be zero. This one is zero.
0.
That's 90.
No, no, no. This one.
Minus. Minus.
I'm coming.
Okay. 90. This is to be going clockwise. That's 45. That's 45.
That's 45.
That's 90.
125.
Hmm? So I think you understand what I'm trying to say now. So positioning this, I'm coming. This angle, as it is now, this angle is different from this angle because it has what polarity. But for a capacitor, copy. For a resistor, sorry, for this resistor, it has no polarity. It's like this or like this. You understand that? Sometimes we don't used to stress our pick and place machine, or sometimes it will just calculate. Is that 180 or 0? So if it is taking 360, we don't want to stress the nozzle. You understand me now? Because the nozzle will pick it and still rotate it. The same, since it is the same polarity, but you are rotating it. So that's what we call optimization. We call it optimization in pick and place machine. Because I've operated pick and place machine very well. Optimization, so that the machine will pick and place all those components faster. So it won't, any component without polarity, we make sure that it doesn't stress the what? Nozzle. Nozzle. Have you seen a pick and place machine before? A pick and place machine, the one we have has 8 nozzle. It's 8 components at the same time. It uses air pressure to suck the component from the what? Component feeder. I don't know how you explain it. So once it suck it, it places it on the board at the same time. So that's it for this. So let us do the what? Pick and place file for this board. So you can see how it looks like. So let me talk about the step 5 too. The step 5, maybe after you finish your PC design and you need an enclosure, because there are the software I'm familiar with, Cam 360. Yes, Cam 360. I just learn how to use it, but I don't really. I no, I learned how to use it. I understand how it works. Use it. So just that. So when I see it, I can still do 1 or 2 things by myself. So that's it. License is not yet expired. No, the reason why I do learn most of anything that relates to electronics is that if I give you a work to do, I know the time frame. You can't just lie to me. I'll tell you should have finished this thing. So that's it. I learned that from one of my boss. Any new machine they brought like this, you will learn how to use it. You know the time frame. So if you just tell me, hey, it's the kilometer, you are lying. That's it. So sometimes if another department is created, you have a new department that springs under your department. You have the best thing is to pass through that stage, you know all the process. Or else, I'm saying, man, you know, but when they know that you know the process, that's one. Because me, I started from electrical, pure electrical. I started all the stages in. I started from electrical being. I did domestic installations, industrial installation. From there, I joined metering. I started doing all this residential metering, industrial metering. From there, I moved to meter repair. From meter repair, I moved to test bench, meter calibration. From there, I moved to meter aging test. Not only meter, aging test is purely for electronics. You can do aging test for any device. For your laptop, you can use GPS where you set them to different environments, condition, and all those things like that under electronics. Then from there, I moved to PCB fabrication, PCB lab. I work in PCB lab. I fabricated PCB, I did everything. From there, I moved to SMT line. I learned how to use all the machines in the SMT line, the whole process. I did soldering, everything. From there, I moved to assembly line. I assembled the line, I supervised, I did everything. Then from there, I now moved to R&D department where we do research, and so nobody can lie for me in any department. Eh? I'm sharing the knowledge.
He's too young to rest in peace.
Once I'm 40 years, I am not working again. What you try? I
You are
started
not
early.
working. You are still very young, though. At 40, you are not
No,
working.
I started early. I started working early at the age of 16.
At the age of 16.
Now I'm 40 years, I don't want to work again. I don't want to stress. I can just be doing this work, share knowledge, and yes, now consultants.
Consultancy fee.
Where I see money most now is a recommendation. People just come to me, okay, which product should we go for? This, or this. I'll charge you. You pay me
Before you now tell me.
yes.
Yes, that's you have to, because that's consultation fee.
No, wait, I don't understand that. At what stage will I be?
Eh? Consultation now. You are consulting me for my service now. I will list up.
The same way we used to pay in hospital.
No, mommy, wait now. I understand.
If I open my email for you, I will give you condition. Okay,
Even
if
when the doctor has
I get to this stage, you are
solved the
paying this
problem.
amount, you are paying this amount. That's it.
They go for that.
No, for instance, I'm bringing up the machine now, and I'm consulting.
Okay, right from stage before you, I will give you my conditions, consultation fee. You see everything. Now this is for you.
Anyway, consultation fee must not be other that will drive the person away.
Most times, if another person give another person, at the end of the day, they still come and meet me and give me work. I just go to part of the table and I want to come back.
And the money they are running for.
They will pay you.
Yeah.
So that's it about electronics. You know, when you have passion for something, just that. I have known all this thing before I even go to school.
Okay. No, there's no aspect of engineering when it comes to practical.
Uh-huh.
It's not about you are a graduate.
No.
So far your brain
I
is to the
still back school results. I only use my professional certificates. There's one from UK, South Africa, and India.
Okay, that's the secretary of job diplomas.
Securing. Mumas don't value certificates.
They just take you for
What you do.
I didn't get to know what you do.
Interview you now.
Any practical.
Interview you.
by practical.
Don't employ based on.
By learning, by learning it practically.
No, what you know, that's how we employ it. We don't use qualification.
Okay, for instance, if there's put an advert out, you say you want somebody.
That's one thing. That's one mistake people do sometimes. Do you know that sometimes, especially when it comes to high tech or tech companies, even though they put BSc, master, and you know your words, go for the interview. Mistake, how we imagine it. They will look at because the state this, so you don't know.
The challenge is that if the recruitment is outsourced to HR company,
Most times,
screen out.
no, but everything is changing now. Because there was a time all these companies they were complaining that this thing is giving them problem. If you can see now, they come up with an NSQF. I'm also a trained assessor now. I'm a trained assessor.
Okay. Sorry, I'm hearing that for the first time.
If that much my gem, so that's the challenge. So step 5 now, we are talking about step 5. When you export step 5, the step 5 is what will help or assist the person who is going to what design your what enclosure. So you don't need to be sending dimension or do any drawing
Come
for
again
him.
concerning that step 5.
Step 5 is a file you export
Okay.
in order to give the person who is supposed to design your enclosure. It's useful for the person to design the what enclosure. So you don't need to do any drawing or start drawing and giving dimension. Once you send the step 5 to the person can easily what do his own design, even have animation of how the what board goes inside and you see it.
You need to case here.
Yes. Straight.
And one problem in this part of the world is that even when you design, the internal panel is neat to get a
No,
fabricator
once you give them the step
design.
5, they will do it. The step 5, this once you give them this PCB, in the step 5, they will see it. It will look. I don't know where I put it on my system. I'll show you one.
So it will be brought out on 3D.
Yes, they will be able to open it on that software, and they'll be able to even do the enclosure. You see it, they can do animation of you how it's closed, and you can.
And
They
the
can.
software will be sent to you.
Yes. No, then they will use a 3D printer or any means to print out the enclosure or to make the mold. Because normally prototyping is done using, for now, prototyping of enclosure, we make use of what 3D printers. So if you make use of 3D printer and you check it, everything is fine. And if you want to go for mass production, that's when you now go for what? Mold. Injection what? Mold. So this is where you export it. You understand? So you can see solid. So once you export it, press OK. You get the file, just send it to the person. He knows what to do. Everything will be fine. It will be perfect. So that's it. So another thing, I've explained what we call BOM, right? So now let me show you how to export all these files. How to what? Export each of those what? Each of those files. So now just come to file. I just want to put title sheet on this. You didn't set up title sheet for your PCB design. Title sheet now. I explained yesterday now. I'm coming. I'm coming. Let me just check it. What's a lock mistake? This software is very friendly to use. That's what I like. This is how our project should look like. Then, for example, when you have a bigger project, then go project in Pogo, and okay, so this is how it should look like. Then I think this is a power supply. Now, the details about the title, this thing, put it there. And just say what's the this thing 5 volts? You have power supply. That's what I want to write. I want to write that. Just put it to. You understand? I'm coming. I'll still show you everything. Put the title, description, and some other things here. You understand me now? And maybe you have sometimes if you do some design, you have version one. After maybe your first two prototype, you have version one of the first prototype. You make some corrections. If you make some correction, you have another what version of PCB due to maybe some little errors. If you are doing the second version, any additional changes you do, you can use all this space here to what type and put it. So it depends on the type of what title page you want. There's portrait too. Click on portrait. So it has more. So it depends on what the name of the designer, all those things like that.
Specification.
You see it there. Come on. Yeah, you see. You see.
Okay.
Designed by your name, checked by, approved by, date, file name. You understand? Edition sheet. So you can just go through all those words. Title page. Use it here. File. And sheet setup. We
Do you
have
do
different types.
casing fabrication here?
Hmm?
Casing fabrication, do you do it?
Casing, PC, enclosure.
Uh,
We brought a 3D printer, but that is where there's no time. But I think some people still have to come over to our place to learn all these things. There's a 3D printer there.
Okay, for metallic casing
For
and
enclosure,
also
no.
it's for
Plastic,
plastic.
yes. So you can as well go through this by yourself, all these templates that can be used. And so now, under this file now, we can do what? Import. Import is when maybe someone give you a what? A GABA file. So assume someone give you a GABA file from another system, from another software, or even though you use deep trace. Hello? Even though you use deep trace to do your design and you export the GABA file, if you send it to that person and the person use deep trace to import it, you will only see what? Layers. It can't do anything. It can't ask information. It doesn't have information about what? Your design. So that's it. So for us now, we can export what? GABA file. We can export what? DRI file. We can export what? Pick and place file. We can export what? Bill of what? Materials. So let's start from GABA file. Can you see? Export what? GABA file. So now you can leave this alone, offset. Then most times you can use what? This is better just say use design origin. Let me explain this to you. I can only explain this because I have experience about fabrication. You know now, in your machine, when we talk about X and Y, this is coordinates, right? This is the coordinates. Right? So if I said offset of 10, if you now shift your PCB design to what? 10. Offset of what? 10. You understand me now? So that the machine can work this way. You understand? So, but if you say use divine origin, it makes of this place. So when they want to use their own software there, they can set it to what? Offset of 10. Yes. Look at that. X and Y. Yes. Just to set. Yeah. So that's the meaning of that. So then you can metrics. You can see metrics, not inches. So that's it. So here now you can what? You can see what top assembly will show. Text, tables, picture. So once you select it, this one will show what? Parts, mounting hose, text, pictures. You can see what they carry. You understand? You can see it. Then you can as well preview it. Okay. I know. This is one layer. You can say top 6 layer. So this is what the person will just be seeing. You can't move anything. You can't edit anything. But you can view all the layer at the same time. Do you understand what I mean? So that's it. So these are what you are what exporting. So you can export one layer or export what? All. So if you export all, it will ask you if it should. It's doing everything automatic for yourself. So you don't need to go back and go and export which G file again. So it's showing what? Zip archive GABA plus what? NC dreams. You can see. Let's put context up. PSU 1 of GABA. Save. That's all. Then if I go to my desktop here, I see it. If you open it, you see them. It has opened it. Can you see it? And you can see the extension. The extension is what? Dot what? But this one is what? Dream. So you only have one dream, and why others are what? GABA. So that's all. So now, this is what you want to do. This is what you have to give the what? The lab, the fabricator. This is what you have to give them. Do you understand? So now, that's for that. We are through with that. So, which other one are we going for? We've done GABA and G. Let's see how pick and place file look like. Export. Pick and what? Place. Do you see what is given? Can you see all the information? It will give the what? Ref desk, name of the component, pattern, center, which is the center Y. You get what is this is X and Y I'm talking about coordinates. The what? The width, the what? Rotation to now, and what? Value. We still have more information that you can add. You understand? You can add more listing, more information here. So I can add a description. Click on add. You get me now. So now let us export. Which next page you need? Let me just put one or two so I can. Is it desktop? Are you?
So you sync it to G trace.
Should this one be semicolon or comma, comma. Okay. So then we find one up, right? Where did I save itself now?
Save it to the drip trace folder.
Yeah, could you just folder?
Document.
So we space it. Okay, this is open file location. Can you see it now? Can you see the information? All the details. You see the rotation. And it's telling you the what? Side. Which side is the what? Top. Then you remember I told you when you are designing your components, graphical symbol, and pattern, you have to create what? You have to add origin. The origin has to be at the what? Center. So you can see the machine will be picking at the what? Center. So if you don't define origin for it now, it will for it to get the what? Components for placement on the board, it will be what? Wrong. No, it won't be difficult. It will pick it successfully from the feeder, but it will place it wrongly. So these are the details you get from your what? Pick and place file. So any company that is doing that pick and place file, this is what you are sending to the what? Company. So that's for it. Then the next one is what? BOM. Before this result, they don't have all this thing, but they've advanced. Even now, this morning I realized that they've come with another version, Deep Trace Beta. It has simulation. Last week, I checked it this morning. Hmm? You can see. I downloaded it. Deep Trace.
Okay, so this one we can simulate.
I'll have to go through it, learn how it works.
I hope
Not
that
now.
you share it with us.
That's when I get back.
So it will not be useful for the next 3 years.
So that's it. So now the next thing we are going to do is we export what? Bill of what? Materials. You see how it would look like. So, right? You're okay with this? You also have interactive VM. If there's internet connection, it will tell you where you get all the components. So I don't want to, because once I print it out, this is what it will give me. I don't want to export it. It will be in the Excel form. It's not useful for me. Can you see it now? It's telling you that C1 and C4. It's not putting the ref desk on one number. It will tell you, okay, since this C1 and C4 are the same thing, you understand now? C1 and C4. Name. Quantity is what? 2. So this list alone is okay for you to send to the person you want to buy the components from. Okay? So you don't need to start saying, can pastor make the one be by? Pastor make the one be by. So with just this, you know that okay, this is what I need. And this one is per board. Am I right?
Yeah.
So if I'm exporting this, it will be in Excel. So the next line in your Excel sheet, you just say per 7 boards. So you just say multiply by 7. Just drag it down. You understand that formula in Excel? So you have the total components you want to buy. You don't need to start listing everything. So now I want you to export your Java file, your G file, pick and place file, step file, and do your. Yeah. Do it and put it in one folder.
Please come and take your
Forget about what you are doing now. It will work. Oh. Forget maybe you've not finished your design. No, you can do it without. Yeah. What?
I just discovered that my own shape, this pattern, she don't look like yours.
Yeah, they are the same thing. They are the same thing. Just look like that sometimes. So now, yeah, start. Let's start. I want to see it in a folder. How many files? Java file with tree file, pick and place file, step file, and what? BOM.
You see, you should both import and export.
No, export it. Import is when someone sends the file to you and you want to open it on your system. Export is okay. Oh, I want to send it out to a fabricator and to a company that will what? Place the component and make order for the component. I'm waiting. Oh, I'm going to go through.
I think there are five. Okay, Java and then step five. Place for everything. Step five. I don't see that step five. What are this one? I can only see pick and place. The bill of material. Those are the
Should I include the back? There is a step farm.
Does your own bring this dialogue books? Does your own bring this dialogue books? And I want to after this point to come. Yeah, just
No, no, because it's CSV.
just column divider. Yeah, I just maybe you want to the number of column I put six. I just put six there. But it's expecting us to do something.
CSV for
Just come out and begin.
So what is asking how many comma what is CSV? So if you see the extension of CSV,
Yeah, so put the of materials, export. Okay, this comma.
the bill of materials, the other one.
I've saved it. That's why. No longer. I think that bill of quantities fine.
That's different from click on save.
I've saved this for me. That's why I put it.
There was one
I use it. The file you want to replace.
they're showing you one.
Let me cancel it. Okay, this one is already saved. After bill of material, which one remains there? Bill of material, then Java. You can place. I've saved them. No longer
So
doing
which
that.
one?
I only find three. But in this one, you open many download boxes. From one download box to another one. Because me, I don't see much money in this one. What are those to save it on desktop?
You want to save it. I don't know where you're saving it. You save it on there.
On
You go
desktop.
to there, you can see it.
Where did you go, sir? Okay, this one, bill of quantity.
I said my picture is not I'm not in the picture that I sent to the group.
Oh,
The
you
one
went to the toilet. Send me. I hope it's bringing this up to the house. But you didn't feel like you feel your own weekend.
So your mistake here was
Because of sister, I was like,
yes.
wait, don't do that.
I'm not deleted from Facebook.
Because of sister, I waited. What did you bring all your own?
No,
You know you were sharing one
one
last
is
time.
Because when
Days you were supposed
I
to
received it, you didn't be able to do it. Okay, probably I should just delete it.
we are looking down now. All the pictures.
Or maybe I could show people something.
Starting from this point, let me see your persistent.
You know, this picture. You know, like you say, it's not as very interesting.
What happened to them yesterday? Finally, what happened to them? Why do you have to do this? You're correct. Yeah, that's what was. I said, don't worry about your hands. You can still do it without. Just do this. Gather file. Export to gather file. Click on this file. Take file. Do it there.
Do it again.
Even the Java file I saved, that's what I'm not finding. It was that Java I said saved on desktop. Okay, or maybe I didn't save that one on desktop. It's still Java and I just want Java.
Say Java.
Uh,
Java.
Java. No Java.
Maybe you should okay, this PCB design Java. I mean,
Do you know this mistake? Go back to gather file. No.
This is just what my brother.
That's what you for me. That's the way I told you to what? Export it. Yeah, go back. Go back. Try to export. Yeah, you gonna this week and please. I said Gaba. Gaba, you said you okay, pick and please. That's it and please. What about no? What is pick and please? Let's use if I like see you go back again, I'll tell you. See, colon divider. This thing, it is there. If your colon divider is common, this
That's it. That's it.
so you remember this? I think
Wait, that's put it on Excel.
you don't you did the same mistake. Hmm? And you've gotten the time. That's what I'm saying.
Finally. Telling me that okay. Bring it to that the one that we did yesterday. That's why you not bring that. This one is not even now.
Show me your cover file and your file.
After saving,
And your
this
pick
one
and
is I've saved it now. I'm just closing it down.
so you see the others are you can't access. Where's your pick and place? Where's your cover? Open your pick and place. Yeah,
It's not supposed to be. Dimension. Start breaking. It does not follow the column. It's
Check
supposed to be
ISR.
quantity supposed to be under quantity manufacturer name.
I even need to do stuff like that.
Just instead of arranging it.
That's why I'm saying, yeah, go back to it.
Oh yeah, check it again. I must not look at it. You called me now.
Yes.
That should start with Gala.
No, Gaba is okay. You can please. Yes. Not to repeat it. Comma. Not semicolon. They are telling one yes. What I'm addressing
How's it going? Wow, I can see your 3D. What about you? You're on 3D already. Same thing there, right? Great. What course are you doing? Yeah.
Actually, I'm a graduate of soil science.
Soil science. Okay. But you personally working some.
Selling instruments.
Oh.
You wrote yes on the book.
What about you? Huh? Computer science. Same thing, right? Oh, okay. That's good. So guys see it. So the soil scientist now wants to be a fabricator. Oh, that's great. Your name?
We
Your
actually
name?
have like a hub in the university.
Okay. In the universities,
Yes, I mean in the Summit University.
a hub, right? Or a club.
It's a research
Okay, research
group,
group. Okay.
yes, but we
Okay.
have like a hub in the
Okay.
university.
Are you for the female in STEM as well? Okay, you're part of.
Yeah,
Okay.
feelings. Yeah,
Do you know Whiskers and
That of Gaba is
Kaya?
one
okay.
It's like they are based in, they would have been here too. They are part of the team that went to Momas last time.
So all this one,
Okay. What's your
and
name?
what do we do with all this one? Are we in the science?
You know, it's for fabrication. This one you send to the lab.
Should we always
Send
stop
that
cleaning,
product
Abby?
to the lab. That's what they used to fabricate.
Should we stop earlier, Abby? Right?
And stop. And don't you tell us